Good morning or good afternoon, my third period students. Today is Monday, November 1st. Make sure you remember your social skills, remember the rules, remember how we behave with guest teachers, how we behave in general, and you'll be rewarded for your good behavior. All right, so the title of these notes are absolute value equations. I think these were the notes that we took like 2 weeks ago. Like it might be a continuation of it, so just put 2 right here, like Roman numeral 2. We might have already used this title, but we didn't finish those notes. All right, so just to recap, make sure you guys write this down. If you need to pause the video, that's fine. I have to move a little fast because otherwise it won't save on my computer. So we remember the general equation when we're solving absolute value equations is x minus b equals c for c is greater than 0. This general form asks us which two numbers are c units away from b. So here's an example. We have the absolute value of x plus 2 equals 7. Now, x plus 2 is not in the form, it's not in the general equation form, so we could make it into the general equation form so that we know where our starting place is. So we would say x minus negative 2, those are equivalent, right? Because the subtraction of a negative 2 is the same as the addition of a 2, equals 7. So now we would ask ourselves, all right, if I have a number line and I plot negative 2, all right, here's my plot. Which two numbers are 7 or c, 7 units away from b, which is negative 2. So if I count to the left, I eventually end up at negative 9. And if I count to the right, I end up at 5. And the way you can double check or you can verify if negative 9 and 5 are the solutions for x, you could use algebra and you would break it up into two cases. X plus 7 equals x plus 2 equals 7, and x plus 2 equals negative 7, because these absolute value bars, you're taking both directions into account, the right and to the left, the plus and the minus. So let's break this down into two cases. I have to write it up here, but for you, you'd probably write it underneath. So we have x, and I don't need absolute value anymore because I'm breaking it down into two cases. X plus 2 equals 7, and I'm breaking it down into x plus 2 equals negative 7. So I'm just going to quickly solve these to verify if my solutions are aligned. X equals 5, check, I already found that. And then subtract 2 from both sides and get x equals negative 9, which is also a solution that I found by using the concept of the general equation. Now, another thing that I want you guys to recall is that the absolute value of x equals, let's say, any number, okay? You're basically asking yourselves, what could x be? Well, x could be the absolute value of negative 10. And you can write the solution set with these brackets. It could be negative 10. The absolute value of negative 10 is 10. And the absolute value of 10, there I go drawing parentheses when it's brackets. It's not a point. That's why we draw brackets. Brackets represent a set in math. So this is a set. It's not a point. So you have to put those squiggly brackets. So negative 10, the absolute value of negative 10 is 10. The absolute value of 10 is 10. So there's two potential solutions here for x. So we say negative 10 and 10. All right, I'm going to go ahead and pause, erase, and give you the second part of your notes. All right, so let's look at a next example. This is where we left off last time we started these notes. So isolate the absolute value. That's like the key strategy to solving these in absolute value equations. So if you look here, we have 6 times x plus 2, the absolute value of x plus 2. So I know that these seem like parentheses, but they're not really parentheses, okay? So since 6 is being multiplied to this absolute value, I want you guys to do the inverse operation of multiplying by 6, and that's dividing by 6. So I'm going to divide both sides by 6. To isolate the absolute value, meaning to get the absolute value by itself on one side of the equation. What I do on one side, I do the other. 6, when you multiply by a number and divide by that number, it's like equivalent to 1, because 6 over 6 is 1 whole. And you're left with the absolute value of x plus 2 equals 18 divided by 6 is 3. And now you can use that general form, and you could rewrite this, and you could say, okay, this is like x minus negative 2 equals 3, and then you ask yourself, what numbers are 3 units away from negative 2? So let's try that, and then we'll do the algebra. I'm going to go to negative 2, and I'm going to go 3 units to the right, 3 units to the left. If I go 3 units to the right, 1, 2, 3, I end up at 1. If I go 3 units to the left, 1, 2, 3, I end up at negative 5. All right, so if our algebra is correct, we should get x is equal to 1 and x is equal to negative 5, or x is equal to negative 5. All right, let's do it. So I'm going to get the original. X plus 2 equals 3, and then x plus 2 equals negative 3. Subtract both sides by 2, and I get x is equal to 1, which I have. And then subtract both sides by 2, and I get x is equal to negative 5, and it matches. So we would say x equals the solution set of 1 comma negative 5. Cool. Sorry that I had to erase that. I just want to keep this video under 6 minutes. Go ahead and try this on your paper. I'll put the solution, pause because I'm about to write the solution. Okay, here's the solution. Yay, if you got it. I'm going to record part 2 of this video, okay? So in the last video, I gave you the answer to this, and I realized now I probably shouldn't have given you the answer. I probably should have just made you wait for this video. But if you didn't get the right solution, I'm going to show you the steps on how to do this. So I'm noticing that the absolute value is being multiplied by 3, and then it's being subtracted by 7. I want to isolate that absolute value, so I'm going to undo this minus 7 by adding 7 to both sides. And then I'm left with 3 times the absolute value of x plus 6 equals 27. And then I'm going to divide both sides by 3, and I get x plus 6, absolute value of x plus 6 is 9. Now I can break this up into the general form, and I can say, the equivalent of this is x minus negative 6 equals 9. I can plot negative 6 and then count 9 to the right and then count 9 to the left. But that seems a little bit too tedious now. Why don't I just go from here and do my algebra? Do those two cases, like x plus 6 equals 9 and x plus 6 equals negative 9. That almost seems easier than drawing a number line and counting 9 and miscounting or whatever. So let's try this. I'm going to subtract 6 to both sides. I get x equals 3. That seems reasonable. That's 9 away from negative 6. And x is negative 15. And that seems reasonable. That's 9 units to the left of negative 6. So it seems like our solution set, which you already know, don't act so surprised, right, is 3 comma negative 15. All right. Now I'm going to give you guys one more example. And this one honestly threw me off. Like, oh no, not this one. I'm going to give you 2 more examples. So the next one that I'm going to give you has parentheses on the inside. So it's 3. So it's absolute value. 3 times the quantity x plus 1 equals 15. So what do you guys see there inside the absolute value? I think I already said it. The distributive property, right? So let's go ahead and just distribute that 3 within the absolute value. So we have 3 times x and 3 times 1. 3x plus 3, keep that absolute value, equals 15. Now for this, I'm not going to try to use the general method. I'm just going to use algebra. We are in an algebra class, right? So let's bring out that algebra. So we have 3x plus 3 equals 15. And the other case is 3x plus 3 equals negative 15. So we have 3x plus 3 equals 15. And then we have 3x plus 3 equals negative 15. Hey, if you want to pause the video now and try this on your own, I highly recommend it. Okay, hopefully you already tried this. Let's subtract 3 from both sides. We get 3x equals 12. Divide both sides by 3, and we get x equals 4. Okay, and then we subtract both sides by 3 here. 3x equals negative 18. Divide both sides by 3. We get x equals negative 6. So the solution set for x is 4 comma negative 6. And you can write negative 6 comma 4. This just means a set, so it doesn't matter the order. It's not a point, remember? It's just a set of numbers. So it doesn't matter if you put negative 6 before the 4. As long as you have a negative 6 in there and you have a 4 in there, you're good. Now this other example was the one that kind of tripped me up. So I want you guys to actually try it first and see what I mean by it. Try to use the general method with this. Just try. All right, so hopefully if you worked on this example, you noticed something after you divided both sides by 2. You have the absolute value of x minus 7 equals negative 2. Now think about the general form. How can you have negative 2 away from 7? Better yet, is there a number you can plug in here where, like, let's say we put 5, right? Let's say we put 5. 5 minus 7 is negative 2. But what's the absolute value of negative 2? Isn't that 2? So the absolute value of negative 2 would never be negative 2. So if you have a negative number here, think about the general method. The general method is x minus b equals c, right? For c greater than 0. Negative 2 is not greater than 0. So the general method doesn't work. In other words, this equation doesn't have a solution, because no matter what number you plug in for x, you're never going to get an absolute value of negative 2. Absolute value is distance. You can't get a negative distance. So this is no solution. Okay, so after this assignment, you guys are doing Edulastic. You're allowed to check your answer once. I may or may not watch you guys on Go Guardian, so make sure you're on task and make sure you're not cheating, because even if I'm not watching you, the math gods are watching you. Don't cheat. You can do it. You can do hard things. I believe in you. Be good. I will see you Wednesday. Bye, guys.